Yay! So this talk will be somewhat technical, but I'm trying to explain this in the simplest way that I can, and I think it should be pretty simple to follow. Yeah, it's me. My name is Ron. I've been helping with B-Sides / LongCon forever. This year I didn't really do the organizing beforehand. I'm just here on site. I work for a company called CounterHack. We make CTF challenges and other online stuff. Every year we do a big CTF called Holiday Hack Challenge, it's a free online CTF. This year in particular, we're doing KringleCon. So every year, Santa Claus is attacked by some supervillain. This year, Santa's gathering all the hackers together at his virtual conference at the virtual North Pole to stop this once and for all. ... So right as of now, we have some parts of it open to play. There's some Easter eggs, some maps, some things to see. Thanks, Aaron. So check it out, kringlecon.com. I'm in charge of evangelizing. So this talk in general will be about binary analysis. And I want to in the big picture, I want to talk about binary analysis more because I've been doing pen testing for about a year, and then every pen test I've done, which is about 5, binary analysis in some form has gotten us a big victory. This will be a very specific one, however, about WebExec, which is a vulnerability we found in the WebEx client that we disclosed about 2 weeks ago. If you're curious to see, all the information from these slides are all at webexec.org as well, but I'm going to present it differently. So the problem with pen testing for me is I don't really know Windows that well or domains, but I know how to break programs. So the only tool you have is a hammer. Every problem looks like a nail, right? So every pen test, we want you to look at this Internet of Things device. Oh, look, there's firmware. I'm going to find a vulnerability in JSON. Hey, can you look at this network? Oh, look, an exe file that updates domain credentials. There's always something that I find that involves binary analysis, and I think it's a really valuable skill to have. So it can be daunting. What's this exe file do, or what's this .so file Linux do, or whatever? It's not always easy, but there's some really simple techniques that can help you find what to actually look at and what is worth your time. Here's some of them. So for what it's worth, this talk's mostly demos. I just have a few slides to introduce the topics, and then we'll just look at how we broke this. So a few examples of things that we've done on Pentest, which I alluded to: fuzzing firmware images, JSON interface, decrypting passwords from a password management app, escalating to system privileges a lockdown image, which is what this was, getting domain creds from a self-service domain tool. There's lots of things you can do with binaries. And especially, we just talked, the last talk was about building things. This is about breaking those things that somebody else built. Companies have a lot of cruft. We've run into exe files that run on every computer startup that was written in 2007 in VB6. I actually had to run VB6 code to get this to work, which involved a macro in Office. It was really fun, but it's also awful. So the things that I do, and I literally just do these 3 or 4 things every time, and if anything interesting comes up, I dig deeper. If I don't, then I just move on. Run strings on things, and strings-el, that's the Unicode version of strings. I'll show you that soon. That'll dump out all kinds of things. Look at the imports. So what import is on a binary is functions it uses from the operating system or from other libraries. Look at the syscalls it makes, and look at the logs. We'll see all those shortly. But more often than not, everything you need to know can be done from these things. And I'll basically show you how you can write most of this exploit just looking at log files. So the specific scenario we do was assume an employee laptop is compromised. Phishing and stuff will work. We'll get a laptop, doesn't matter. So the company ships us a laptop with a lockdown image. The image was, we had a user account on the laptop, a domain account, and pretty much nothing else. No special permissions, no software, nothing that could give us a starting point really, except for what's in the default image, the gold image for this company. So the goal was, what kind of access can you get on the network or documents or whatever? And there's lots you can do on the network level, but like I said, I don't know how to network stuff. So I looked at the binaries that were installed. Our first problem was we didn't have an administrator account on the local machine, and we didn't have an easy way to escalate encrypted hard drives, so you can't do that. And how do we actually get a privileged account? So let's look at the easy way that did not work, but that can work. So let's analysis. It's hard to alt-tab with VMs. I have use a mouse for one. There we go, target. So this target I installed WebEx on. It's pretty much a base Windows operating system besides having WebEx. So that'll be our target. I have Metasploit here, ready to go. Maybe. Maybe not. Uh-oh, what have I done? Screenshot, not smart as Eric. I have the console for that VM. Good demos. This part's not as important, so if this doesn't work, I'll just skip this demo. Yay. All right. So there's a tool called MSF Venom. First of all, I'm just going to do the simplest possible thing. I'll make a backdoor and then run it by double-clicking on it. So Metasploit Framework comes with a tool called MSF Venom to generate those backdoors with arbitrary payload. And all I'm going to do is take their example and just change the IP address. So when you run MSF Venom, they give you an example. Change localhost. Hopefully the IP of this didn't change. .56.11. So this just generates an exe file that when it runs it, will open a backdoor. And I'll just dump that to /mount/shared/backdoor.exe. This takes a few seconds to run. Bit of water. So this shared folder is just where I copied it to, so it'll show up here whenever it's ready. There it goes. All right, so I have this backdoor. Now I'll start a listener running. If you've used Metasploit, this will be very familiar stuff. Use multi/handler set payload. P. So this will listen for the backdoor connection. And this is all really simple stuff. There's no firewalls, nothing I have to worry about. I run it, it warns me. I run it anyway, as an employee would. Now what you'll see is I'll get a connection from the box. If I look at my user ID, I'm a test user, which is an unprivileged user. If I do something, I think this will be my, nope. If I run post gather, Windows gather smart hash dump, I'm gonna get permissions error. So I can't dump hashes, I can't do anything fun like that. I'm just a normal user. That's really boring. That's the access that we had originally. So now, we were looking at the different software that's installed, and something that came up was program, there it is. So WebEx is installed as a service. So there's the service file. If you're on services.msc, you'll see it in here as well. Cisco WebEx service. Keeps your software up to date and secure, LOL. So as this unprivileged user, I can start the service. It's gonna fail, but I can start it. So like instantly, like I have permissions to start this. That's not good. The second piece of this is this folder. As an unprivileged user, I can change it. I can move something out of it. Oops. So if I just take this back door, whoops, let's get this in the right place. If I move the back door into here, files open another program. Okay. Copy it over here. Rename it to WebEx service. And then let's start this listener again. Start the service. And look, I get connection as a system. So now I have full privileges. And I can, as my favorite example is, because it looks cool, is dump the hashes. Oh, is this recorded? Uh-oh. You'll see the password in the next demo anyway. So this is going to fail. It'll kill in 30 seconds. That's fine. You can make a real service if you want. So this seemed really good. And we tried that. This company used application whitelisting, so we couldn't just replace the service with our file. We tried all kinds of things to bypass whitelisting. Nothing worked. But what we did learn is that WebEx service, that's the wrong one. What did we learn? A service in a readable, writable folder is a huge risk. Even if we couldn't start the service ourselves, we could replace it and wait for somebody else to start it or reboot the machine. Like that'd be a big win if the customer didn't use application whitelisting, which completely wrecked it. So yeah, we spent the better part of a day trying to figure this out. Eventually, I'm like, what does this WebEx service actually do? And this is where the binary analysis part starts. So I have that load on my analysis machine. So we'll use IDA. You can use various tools like strings and stuff for most of what we're doing, but realistically, IDA will do everything I need. So 2 things I mentioned earlier, strings and imports. Let's take a look at those. So I know the font on this is kind of small, so I'm not going to dwell on this slide too much, or this screen too much. I couldn't find a way to make this font bigger. But if you look through this, you'll see lots of service stuff. Update service description, create service, lookup account, log version. These are all different permissions, SC debug privilege, SC token. These are all like service things, which is not super interesting. That's probably just for creating a service or whatever. Then we see other things that are more interesting, like software update and wait for a command executed and the service was uninstalled. The service was installed successfully. Like all these things sound kind of interesting. So what does this actually do? So what does this actually do? One of the things, the other piece is imports. So the imports are the functions it calls from, in this case, just from Windows, kernel 32 system stuff, doesn't matter. The thing that I saw instantly was this one, create process as user. This service, in some way, can start another process. If we can make it start a process that we wanted to, then we have a process running a system, and then we're finished. So how can we do that? Well, I had a good feeling when I saw this, and it's a pretty short program otherwise. So I'm like, okay, let's dig into this a little bit. We're on customer time, why not? Oh, this is being recorded. So if you Google create process as user, you'll see it takes a bunch of parameters. All the parameters are right here. The application name, the command line, token, blah, blah. What we really care about, if you read the API description, you'll see the token and the command line matter. The token means what user runs as. The command line means what it actually runs. So I'll go really quickly to this function because it's a lot of gobbledygook if you've never seen assembly. But what we want to look at is the API calls. Create tool help 32 snapshot is a Windows API. If you Google it, you'll find all the information for getting a list of all the processes that are running currently. Then process 32 first and process 32 next. Go to each process. Basically, this finds a process that wants to open a handle to. None of this will matter. It's just this process of looking at what's happening is really important. Open process token, duplicate token, close process, then create process as user. This sequence of calls is extremely common to create a process with a privilege of another process. If you take 2 or 3 of these and Google them, you'll just find a bunch of commands doing that. So you can figure out exactly what's happening in this function without ever looking at the assembly really, just what's being called. So the process is creating things under is winlogin. Winlogin also runs as system, so that's a really good sign. Basically, what this function is doing, it's getting a handle to winlogin, winlogon.exe, and opening another process as that user, which is system. So okay, we want this function to happen. How do we make this function happen? That's the big question here. So if you look around this program, you'll see lots of everything. What I care about is there's a bunch of error messages that are used throughout. If I go, I'm just jumping through this fast. Error messages and log messages, execute service command, command not recognized, stuff like that. Where do those get printed? If that's a log file, I can start using those error messages to build my payload. If it's the Windows event log, same thing. And if you look in this function, it's the Windows event log, register event source, and report event. Okay, so it's reporting all of the stuff it's doing to Windows event log. Let's see what that looks like. And that's the end of the assembly part, basically. All right. Event viewer. I need to run this as administrator. Obviously, we didn't do all this on the machine from the customer. We did this on our own machine, the analysis. So it's a bad password, I know. So I mentioned earlier I don't Windows, so I just make a log that contains everything, and Windows logs is where the services are. Occasionally it gives me errors saying there's too many log files, and I just press OK. People who actually do this are laughing at me, but that's okay. All right, so here's the logs from stuff happening. Then I'm going to open a command shell. Again, this is a completely unprivileged user. I should make this bigger. Properties, font. That's the biggest. Okay, good talk. There we go. Oh yeah. Okay, so let's just start the service. Let's fix the service, then start it. So delete the evil one. What did I just do? Delete the evil one. Replace it with the real one, I hope. And then try starting it. It's going to start and immediately stop. That's just how the service works. I can start over and over again. It just starts and stops. Okay, what's it do in the event log? WebEx service runs with a warning. It has an information and warning each time. The information says, you're running version blah. Okay. The warning says, not enough command line parameters. Oh, okay, let's have some command line parameters then. How many do you want? A, B, C, D, E, F, G. I have a whole alphabet. J, okay, whatever. Run it again. It starts, it stops. What's the event log? The event log says, service command not recognized, B. Okay. What else do you have? Service command. Then this says service command not recognized, service command. Okay, what does it want? We're gonna look at the assembly again, just for a second. We're gonna look up what's service command not recognized. Service, did I do it? Yeah. Service command not recognized. Oh, look at that. What triggers this? Let's look up a bit. The string software update is there. That sounds like a string. Let's try that. This is, don't tell my boss, this is how I work. Yeah, software update. Now what's new error message? Application error, the program crashed at, uh-oh. Now I've broken something. So this jump right now is what took me most of a day to figure out, because I totally missed a very obvious thing. So the application crashed every time I tried anything with the error code of 40000015, which is, if you look it up, is an abort. So something went wrong and the program aborted and just bailed out and said, I can't handle this. What is it? So this is, I had to debug, I had to figure out a bunch of stuff. If I just went into the function that's called and looked a bit, the first thing it does really is do a bunch of math stuff, XMM0 and all that. And WCSTOD, that's a function, again, just Google this function. It converts a number to a number string to a number. So the string 123 to the number 123. And then if it fails, a bunch of errors, error out of range, error this, error that. It just wants a number instead of a letter. That's all it wants. So that took me way too much time. So I'm gonna change C to 1. That's a good number. We run it, we check the error log, and it gets really slow. That shouldn't happen. How I sorted it. Oh no. What have I done? Remember kids, never Windows. Okay, now it's the opposite order, but it's okay. We're almost done in this. Our new warning is start update process, create process as user with parameters DEF. Oh hey, that's what we wanted. What if we change DEF to calc? Hey look, calc is running now. So we just used WebEx itself to run our own program. And if we can run things like CMD, those are assigned, so we can run those just fine. If you run this, that, calc is running as system. Yay! So that was really cool. Then we ran CMD and nothing happened. And I still don't know why nothing happens. It's a mystery to me. But we figured, how do you start programs? There's many ways to start programs. So I used, yes, Mac, I know, and yeah, guys. So I don't know why, it beats me why, but WIC process call create CMD does work. I don't know why, but it runs a system. So yeah, now we had a way to escalate to a system command prompt on the image that was locked down. All right, so I have 5 minutes left. All right, so we learned that WebEx service is basically sudo, but with no password. It's great. So we used this. The customer was happy. We were happy. Everything went well. Then a week later, we're reporting this to Cisco, and my coworker says, "Can't you start services remotely?" I went, "Oh crap, you can." So let's do a demo. So from the analysis box, this requires a little bit of windowsing. I'm gonna make this font big again. Properties, I know how to do it this time. Font, another one, there. All right, so first of all, you have to start a session against the other machine using the account that we have. You need an account. This can be done anonymously, but it doesn't need to be a good account, just any domain account. So we're gonna do netuse/u test user is the account that we're using. 192.168.56.10. That opens a session. I give it my password, which is also test user. And then we run sc 192.168.56.10 start WebEx service a software update 1 calc. I missed the T in start. I'm just going to go to this and close everything so you can see that this is real. And then start it, and calc starts. So now we have a remote vulnerability. So we run Metasploit module, because that's what you do. So find Metasploit again. We're going to use exploit/windows/smb/webexec. We're going to set our host to our target, 56.10. We're going to set our payload to Windows interpreter. Set that host. And exploit. Uh-oh. Oh, I had to get an account. Set SMB user, test user, set SMB pass, test user. So it's going to upload the payload by having the maximum length is about 200 or 300 characters. So it's going to upload each one as a VBS script in base 64, then decode the whole thing, run it, and we have a shell. Yay! A system using a low privilege account. So that's WebExec. Next demo, I probably did this demo. Yeah, I forgot when I was practicing, so I put that slide in. So once we found this, we told Cisco about it, and they were really cool. They went back and forth a lot. They got our advice on patches. I think their patch might be insufficient. If you want to do some research, you could probably find bypasses in their patch. But they patched it last month, and now I can talk about it, which is really nice. Webexec.org is my site. We talk about the patches. We talk about the vulnerability. The whole talk, the step-by-step, is all on that site. And yeah, that's all my defense. I've got a friend, I don't know if he's here, Rich, might be around. But whenever I tell him, I found this cool new vulnerability, he always says, how do I fix it? I go, oh, yeah. So I always put a defense slide at the end in his honor, even when it's really bad. But yeah, anyway, that's a very quick intro to binary reversing, just using error messages, logs, and strings to figure out what's going on. So I think Max, give you my get off the stage. Yep, time's up. Is lunch ready? Okay, they are setting up lunch, so while they're doing that, I can take some questions, and then we'll break for lunch and restart wherever my schedule went. So any questions? I know that was really fast, but all the information's on my website. Yes, Eric?
Do you have any hints on the patch?
Do I have any hints on the patch? Yeah. So the way the patch works is it makes sure that everything that WebEx runs is signed by WebEx. So it won't just run an arbitrary program like CMD or calc. It'll instead run only Cisco-signed stuff. If there's a problem with other Cisco-signed stuff, that's not something I can talk about. And so I think that's it. Oh, Emil.
Yeah. How is WebEx updated? Does it have a self-update, or does a sysadmin actually have to go around and patch everybody's computer?
I mean, this whole talk was about WebEx update.exe, so I think there's an updater. I don't really know how it works. On the website, on Cisco's advisory, they give instructions for both corporate and for individuals. I know for individuals, it's to go click in the corner and press check for update and just automatically installs it. For corporate, I'm not really sure, but there's instructions. Yeah. Yeah, there is a monthly update, and it was part of that monthly update.